video on processes. Now, this is fitting in the industrial technology stage 6 preliminary syllabus. We're looking into industry-related manufacturing technologies. We're looking down into processes, tools, and machinery. And then we're specifically looking at planning processes. So that's where we've drilled down to in terms of syllabus. In this particular component, we're looking at planning processes like sketching, working drawings, probably the difference between the two, getting a bit of an understanding between those two different things, materials lists, calculations, costings, and maybe we're going to have a little bit of a chat around the process of ordering timber. Might be particularly useful when you're starting to think about your major work in year 12 and how you go about actually ordering timber with a timber supplier. Now, by the end of this series, you should know about the tools and processes and machinery available, so specifically processes at the moment, knowing which of those are industry-related processes. So we'll mention what the industry expectations are there. And then the key thing here is we need to be able to talk about industry processes that we can know about, but not necessarily do at school. So we'll talk about the things we try at school to mimic industry, but we'll also talk about things that happen in industry that we can't do at school. So it's all of the things that are industry standard, not just school specific. So let's get into it. In terms of the planning processes for a project, it starts with an idea. And that's a no-brainer, but usually the idea comes out of, we've got a woodworker, that could be you, wanting to make a project, and so you've got your own idea. Or there could be a client, that could be your parents in some circumstances, who have come to you and said, I want this produced, and then you as the furniture maker then run with their idea in the production of a furniture product. So we start with the idea. Once we've got the idea organized and we roughly know what it's going to be, we start with sketches. The sketches that you do on that day when you've got that first idea and you have a rough idea of it are definitely not your final sketches, and they will never be good enough to go straight into SketchUp, draw it up in CAD software, and then walk straight into the workshops. Those initial sketches are initial sketches. The sketches gradually develop over time. The sketches will change as you do research into different machinery, different processes, different tools, different techniques. They will change as you research different materials. They'll change as you research different hardware and different adhesive. These sketches will develop over time, and that is normal, and it is expected, and that is what happens in industry. They start as freehand. So you get your pen, your paper, maybe your pencil and your paper out, and you start conducting some very basic sketches of what you think this product, this project might look like. You might start with rough shapes. So you might start in sort of a very cube or rectangular sort of fashion, and then you might start cutting it away as those sketches develop into something that has a little bit more defined shape and quality and finish. In these freehand sketches, we talk about them having no rules. Now, strictly speaking, freehand sketches are free, but as a bit of guidance, we do have a few rules that we recommend you follow to try and make your sketches as higher quality and as useful as possible. But really, there are no rules. These sketches are probably going to include a combination of graphical drawings, but also annotations, text-based annotations, talking about details, talking about features, even talking about decisions that you might be making along the way throughout the design of your project. Decisions like sizing, decisions like edge treatment, decisions like joinery, all of those sorts of decisions also get documented in these sketches as they progress. My recommendation to you is that after you've done your very first draft initial sketches, you should start forming them into orthogonal style or isometric style drawings. And by the end of it, you should have a combination of the two. Some 2D, e.g. orthogonal, and some 3D, e.g. isometric, so that you can get a bit of a feel of the project from multiple angles. We really are paying attention to what does it look like from the front, from the side, and from the top, because with those details, we usually have enough to start adding in dimensions and moving forward with our project. As you can see in the sample that I've given you, very basic project, just designing a die, okay, 6-sided die for playing a game with. And you can see that title, as it works down, you've got front view, front and side in a 2D view, and then it progresses into that isometric 3D model, okay? Front side, right side, top side, okay? It then goes down and starts breaking that project down into detail. So that next level, as it develops further, is starting to look at the details of where are the circles going to be added, how are we going to determine the spacing, what sort of models or patterns are we going to use, what sort of dimensions. You can see dimensions starting to be added. And we're also seeing a whole heap of annotations, text-based annotations giving additional detail to these sketches. Work our way all the way down to the bottom, and we start seeing mathematical calculations, coming up with those justifications behind the decisions that are being made. Why did we decide that the dice was going to be 70 millimeters wide? Why did we decide that there was going to be a 30 mil spacing between the centers of the holes? How do we know that the diagonal is 99 millimeters across? And that's all through mathematical calculations that are helping to justify our decisions. So our idea is created, and then we begin sketching, and those sketches develop to a point we are now ready to move into working drawing territory. When we're talking working drawings, we are really talking that progression from a hand freestyle sketch, possibly with pen and paper or pencil and paper, that has developed and pushed forward and is now being computerized. It's probably becoming much more technical. It's probably starting to comply with the Australian standard AS 1100 for technical drawing. It's probably being developed in computer-aided design software, CAD software. Okay? It will usually include a front, top, and right side view. It will usually include dimensions, and it will usually be drawn in a scaled fashion. Now, it may be to a known scale, so maybe a scale of 1 to 2 or 1 to 5 or 1 to 10, one of those fairly common scaled ratios. But if you need it to fit on a page and it's obscure size, you really can scale it to any scale you like, as long as all of the components in your drawing are proportionately sized. So it doesn't look too, it doesn't look odd on a page, and therefore maintains its integrity in terms of front, top, and side views. Working drawings you should be very familiar with. We do them in SketchUp. We add a title block. The title block has name of the project, name of the part, the person who drew it, probably the date that it was drawn, some details around whether it's on a scale or not. But the primary bit of information here is shape and dimensions, and enough detail that you should be able to put those measurements onto timber in the workshop, make some cuts without making any mistakes at all, and your project should come together as a finished product. Okay, so it's really important to know that the working drawings are the ones that you actually work from. While your sketches that we did in the previous step might have all of the information or some of the information, the working drawings are what you take into the workshop. So our process has been, we have an idea, we generate some sketches, those sketches are developed over time, progressed, become more formalized, and then we officiate them and put them as working drawings into CAD-based software. From here, our process moves forward into starting to develop a materials list. In materials list, this is where we start looking at, these are the dimensions of the project that I have. These are the dimensions of each part. Now I need to know what sort of timber do I need for each part of the project. And we start looking at total length, total width, total thickness. And at this point, it's really important to remember it's okay to go back to your working drawings and make adjustments before you move forward. Don't just try and fudge it and make your way through. You really need to make sure that we're complying with some industry standards here. And the industry standard key that we want to stick with is that there are known thicknesses and known widths, standard thicknesses and standard widths of timber that's available to purchase from the shops. As you're working your way through this material list, if you're noticing that there's a variation between these standards, you need to be aware that's going to involve machining. So you're either going to need to buy larger size timber and cut it down, or you can make adjustments to the drawing, adjustments to the design, so that you can minimize the amount of machining work that needs to be done, and also potentially minimize the cost by reducing timber thicknesses and widths down to those industry standards. Okay? Not always possible, but definitely something you consider here. In the materials list, it's all about identifying every single piece and making sure they're accounted for. It's about making sure that we're aware of the types of timber we plan to use and starting to add notes around whether it might need to be widened from two separate pieces. Because from this point here, when we are generating a materials list, we then transfer it across into calculating the cost of the project. And that's where we go from this basic materials list to then bringing it into individual pieces of timber that we're actually ordering from the shop. Now, you can't go and buy timber that is 550 millimeters long and 340 millimeters wide and 19 millimeters thick. They don't sell them at that size. So this next step that we move towards, calculations and costings, is all about adjusting that materials list to now be specifically linked to standard widths and standard thicknesses. So the calculations and costing project, part of the project, there's a couple of things happening. Firstly, like I said before, we need to adjust the widths and thicknesses to meet industry standards. And we do that by going to our supplier and finding out what width and thicknesses they supply in. On the next slide, I've got some information from Harper Timber. That's one of the companies that I've used in the past. And they have quite a good resource on their website in terms of the industry standard thicknesses and widths that they use. For us, once we've worked out those widths and thicknesses and we've organized those calculations, we then do some basic multiplication. I'm going to turn my annotation tool on here just so you can follow along with me. But we need to get the quantity of part, multiply it by the length of the part, which gives us the total length needed of that type of timber. So if I need two pieces that are 700 millimeters long, 2 times 700 is 1400. That's my total length needed. We convert that in millimeters to meters because in industry, when we start getting to longer lengths, we buy in meters. Okay, so we have a millimeter and a meter conversion there, just so that when we're contacting our supplier, we can give them the information they need without having to try and do the math in our head. We also, as you'll notice in the next column, add in wastage. For someone who is a fairly experienced woodworker, quite confident, unlikely to make a large number of mistakes, I'd recommend sticking with around about that 5% wastage. If you're a little bit newer to woodworking or you're not as confident, you may be thinking that perhaps 10% wastage would be appropriate. But it'll be very rare that I'd recommend anyone to go larger than 10% wastage. Because really, if you think you're going to have that much wastage, you probably need to do a little bit more planning. Once we know the amount of timber we're going to order, so instead of ordering the 1.4, I'm actually probably going to be rounding up to about 1.5. Okay, bit of a standard length there, gives me that opportunity to account for the wastage. I then do the multiplication of how much does it cost per meter and how many meters do I need to get my total cost of that piece. And you'll see when I've repeated that process down, each of them are very small numbers. We add the project up and we might come to a round figure of $30, $100, whatever it might be. But it's our responsibility to do these calculations correctly here, because we then, from here, once we've got our calculations, would go back to the client and confirm with them that they're happy to spend that amount of money. What you don't want is you don't want the client to say, I need a coffee table. You go and create it, costs $900. Then you go to sell it to the client goes, nah, man, I only had a $200 budget. Why'd you make it for $900? I can't pay you $900 for that. So if we're thinking about industry processes, running a furniture business, you need to confirm with the client before you go any further in purchasing the timber. Generate your quote, add in your labor costs, and then check with the client to make sure they are happy to proceed with the job. If not, that's the end of the process and you start fresh with a new client. It's all about sticking to the budget here. And this is your opportunity, if you find that you're way over budget, to start doing some substitutions, swapping in some softwoods for hardwoods when you can, cheaper species when you can, and manufactured boards when you can. Okay, there's lots of ways that you can reduce cost in a project, and it's about weighing up that balance between quality, quality and cost. Okay, there's more to it than quality and cost, but really we're looking at quality versus cost. What sorts of materials versus what cost are we charging? So we've now done our calculations and costings on all the pieces, and you may see here that I've got 140 by 19. I've got that listed multiple times. When I order from the shop, I add those two lengths together. So I add my 0.37 and 0.35 meters together with the 0.35 and the 0.28 down here to get the total meters of 140 wide timber that I need. Okay, so that's probably the process that we need to think about, because that helps us move forward into preparing to order. Now, when we prepare to order, we've finished our costings list, we've got our materials list, we've got our drawings, we've got our sketches, all coming back from the idea. The next thing is knowing what you're going to ask for when you contact the shop. There are a couple ways. You can do it over the phone, you can do it via email, but what I recommend to you first and foremost is that when you call up, you are not making an order. You are first requesting a quote. Requesting a quote gives you the opportunity to check that your personal calculations match the calculations from the shop and identify any errors in either what you've ordered or what you've calculated. When you do your ordering, you need to consider standard lengths and standard widths and thicknesses. So that's that information on the bottom of the slide there. And you've got to consider dressed versus sawn or rough sawn timber. Okay, so there's a whole heap of things to consider. I recommend you stick with dress sizes, and I recommend that you become really familiar with those standard sizes before you make any contact with the shop. When you call them, you can see I've got a little script there. I would be saying something like, "Hi, I'd like to order 2 of 140 by 19 millimeter radiator pine DAR at 2.4. When I say that, it may sound to you like mumbo jumbo, but let's really break down what's being spoken about here. I'm saying I need 2, that's a quantity. Of 140 by 19, that's a width and thickness dimension, okay? That's the cross section of my timber. Of radiator pine, that's the species. DAR, dressed all round, 2.4, total length required. So I'm saying, can I have 2 pieces of radiator pine that are 140 by 19 millimeters cross section after dressing that are 2.4 meters long? So I should expect to receive 2 pieces of timber, 2.4 meters long each. So in total, I should be getting 4.8 meters of timber, and it should all be 140 by 19 millimeter. Okay, so it's all about the language you use and making sure you're saying it in the way that they would expect you to say it. You want to make sure, particularly over the phone, that you're not making a mistake here, because you do not want the wrong timber to be delivered and you have to pay for it. Okay, there's no takebacks here, there's no refunds. The second method is you may be sending it on an online form. Sorry, let me go back. An online form or potentially in an email. And when you are writing it down, you write it slightly differently. You don't write it like you say it, you write it how it's needed. 2 pieces, 140 by 19, so 2/140 19, so that's 2 of 140 by 19, radiator pine DAR, at 2.4 meters. And then it's very clear, length, cross-section, quantity. And if you write your whole list in this order, it'll be very simple for the person receiving your order to generate the quote and to make the correct order for you. So that's what we're thinking about here. Having a think about it, the other option you really do have is going into the store. Okay, I know at the moment visiting stores is not an option that's available to us, but when they eventually do open and we're allowed to go in, visiting the store and sitting down with a salesperson, showing them your plans and getting them to help you work through the process is another method that I've seen taken before by students. Very effective in making sure they get the maximum use of the timber they're ordering. Okay, so they're not just wasting it on standard lengths, but they're actually able to maximize it. And the salesperson there might even be able to help you with any potential errors they're finding in your design. So we've now got our process in the planning stage of our design. It starts with that idea. Those ideas are transferred into graphical sketches, hand-drawn, freehand sketches. Those sketches develop progressively to become more and more detailed until we get to the point where we're ready to add them into our CAD software like SketchUp. So the third step there is working drawings, getting those drawings into SketchUp. We then convert them into a materials list, which then gets converted into a costings and cutting list. And then we make the order with the supplier. Now, along that process, as you're working through in the production of projects, we strongly recommend that you spend some time sitting with your teacher or sitting with another student, getting a second set of eyes to look over your plans to look for any potential issues. The biggest issue that I find, what I've found in my experience, is that students, when they're doing their total lengths, forget to account for the length of the timber used within joinery. For example, they may forget that they need to add 10 millimeters to the length of a timber for a 10 millimeter housing joint. Or they may forget that when you use a dovetail joint, you need the full thickness added to the length. Okay, so there's a few little finite details there that we know from experience and logically make sense, but if you're not looking for them, it's very easy to forget. So getting a second set of eyes before you move forward with ordering your timber is strongly recommended. All right, everyone, that's been the planning process. I hope that's been nice and clear. In our next video, we move forward into the preparation of timber. So once you've got the timber in the workshop, what you need to do with it before you can go in and start assembling a project. Hope that's been really helpful and look forward to seeing you again in our next video.